Okay, so question number 3. The rear side, which is the back side of a truck, is open and a box of mass 20 kg is placed on the truck 4 meters away from the open end. If the truck starts from rest with acceleration of 2 meters per second squared on a straight road, find the distance the truck will travel when the box will fall off from the rear side, given mu is equals to 0.15 meters. Okay. Now, before we start trying to answer this question, you have to understand why, as we are told, if the truck is moving forward with acceleration of 2 meters per second squared, the box, which weighs 20 meters, is moving backwards. Do you know why that's happening? Do we understand the reason why, if something is accelerating, the key word here is accelerating. If something is accelerating back forward, the truck moves backwards. A good example of this is the reason why when you are in a car, you wear a seatbelt. Okay? If the car was just going in front, it was always accelerating, there would be no need for you to wear a seatbelt. However, you need to wear a seatbelt because at some point, the car can come to a sudden stop. Depending on how quickly the car comes to a stop, if the car suddenly comes to a stop very, very quickly, it means that the value of acceleration, the size of the acceleration which the car undergoes, is going to be large. Is that clear?
Yes.
Yes. If a car is moving, you're driving a car, then you suddenly come to a stop. Okay? The value of the acceleration is going to be large. This can be the case when maybe you're involved in an accident. If you collide with something, okay? Now, here is the thing to take note of. What happens when you collide? Then you're not wearing a seatbelt. What's going to happen to you?
The body is also going to move forward after the collision.
Yes. When the car suddenly comes to a stop, which means when the car is undergoing negative acceleration, your body does not stop right there and then. Instead, it does something else. It moves forward. So, when you undergo an acceleration, whether it's a positive acceleration or a negative acceleration, in the case of a negative acceleration, when you suddenly come to a stop, your body is going to move forward. And if you're not wearing a seatbelt, you're going to hit the windshield, the windscreen, and you're going to be thrown out of the car. The reason why that happens is because the car has undergone an acceleration. It experiences a force backwards. Okay? That force backwards, whether the backward force is because of the brakes you have suddenly applied or because you have collided with something, so you have suddenly been brought to a stop. You have been brought to a stop because you have experienced a force opposite the direction in which you are moving. You, the person who is in the car, is going to experience a force going forward. That's why you see when there's a nasty accident scene, people have been thrown out of the car and they are injured and they are dead. The reason why they've been thrown out of the car is because when that car came to a stop, it underwent a huge value of acceleration. It underwent a huge size of acceleration. That value of acceleration which the car underwent times the mass of the person in the car. It means force. Acceleration times force. You get pushed out of the car because you experience a force. Is that clear?
Yeah.
Are we clear? You get pushed out of the car because you experience a force. That is what the seatbelt is there to do. The seatbelt is there to catch you, to apply a force in the opposite direction as you are trying to fly out of your chair, in your car, in your seat. The seatbelt is there to pull you back. Okay. The other thing you might have noticed also if you have been in a car is if a car suddenly starts off, it's like you are pushed back into your chair. Have you experienced that? If a car suddenly starts off, you are pushed back in your seat.
Yes, sir.
You have experienced that?
Yes.
It's the same thing here also. However, you are not going to experience this pushing force for a long time because as the car is starting off, this velocity of the car is changing. So the car is undergoing an acceleration. Okay? This pushing force only exists when the car is undergoing an acceleration, whether it's a positive acceleration or it's a negative acceleration. That's when this pushing force exists. If the car comes to a sudden stop, you experience a force which pushes you forward. If the car suddenly starts off, accelerates forward, you experience a force which pushes you back. When the velocity of the car becomes constant, suddenly this pushing force disappears. Have you experienced that? Now that the car is now moving at 30 kilometers per hour constant, this force no longer exists.
Yes, sir.
Yes. So, this force, which is pushing you in your seat, or which is pushing you out of your seat when the car comes to a stop, this force is a reaction. This force is a reaction to the force which is causing the truck to accelerate. Okay? The amount of pushing you are going to experience in your chair is equal to your mass times the acceleration. The acceleration of what I'm trying to say here now is the acceleration of the truck going forward and the acceleration of the box are the same, but they're in opposite directions. The truck experiences an acceleration pointing forward. That's why the truck moves forward. Is that clear? The box experiences an equal and opposite acceleration, same size acceleration, but this acceleration of the box, which is equal to the acceleration of the truck, times the mass of the box. This is equal to the force which is pushing the box backwards. This force here. Is this clear? This is a consequence of Newton's third law of motion. For every action, there is a reaction. Okay? In this case, what is equal is not actually the reaction. It's what is equal in this case is the acceleration. You experience the same acceleration, the box is going to experience the same acceleration the truck is experiencing. okay, the force is not going to be the same, because this acceleration which the truck is undergoing, 2 meters per second times the mass of the truck, that's going to give you the force pushing the truck forward. Okay? But the same acceleration of 2 meters per second times the mass of the box is the force trying to push the truck, the box, backwards. Is this clear? Hello?
Yes, sir.
Okay.
Yes, sir.
It's very clear. Okay, now okay, so we can move forward then, if that's clear. Okay. So the acceleration of the truck moving forward is equal to the acceleration the box experiences due to the sudden forward motion of the truck. Okay. This. The resultant force, the reaction force F R on the box is equal to the product of the mass of the box, which is M is equals to 20 20 kgs, and the acceleration of the truck, which is A is equals to 2 rm meters per second. So we're saying this is the mass of the box. This is going to be the acceleration of the box. Backward. That. The reaction force. Reaction. Is equals to MA, which is equals to that this. Get this. So FR, which is 20 times 2 meters per second, so that gives us 40, right? So the reaction force exerted on the box is 40 newtons. So the reaction force exerted on the box is that is 40 newtons, which is equals to that. Newtons. This reaction force is what causes the box to move backwards and eventually fall off. Okay, are we clear there?
Before we move on,
Yes.
the acceleration of the box, is it going to be negative 2 meters per second?
Yeah, we are choosing the direction. We are only interested in what's happening to the box. So if you want to choose the back direction to be positive or negative, that's up to you. Yes. So that's where we're coming now. Since the box is moving in the backward direction, or is moving to the right, we choose this direction to be positive. Okay, that therefore positive as the box moves backwards, it experiences friction. It experiences kinetic friction between the box and the flow of the truck. Okay, this friction tends to oppose the motion of the box, therefore points in the direction in which the truck is moving. Is this clear? This bit?
Yes, it's clear.
Okay, so we get the friction, we get this friction force FF as follows. Again, FF is equals to the coefficient of friction, mu k, times Fn, the normal force. You're familiar with this?
Yes, it's familiar.
Okay, next. Now that we know the friction force, the next thing is the box. The box does not fly off the back of the truck. The truck as it moves. This shows that the weight of the box, mg, and the normal force, FF, Fn, Fn are equal but opposites. Opposite in direction. Thus we get following. Thus we conclude that Fn, the normal force, is equal to what? So we make this conclusion that Fn is equal to the weight. This, because our box doesn't fly off the back of the train in the y direction. So if it's not flying off, it means that the normal force is equal to weight. Is this clear?
Yes.
Therefore, we wake up, we find the friction. Therefore, we get our friction force as in numerate FF being equals to mu k. What happened? K mg. So this becomes our friction force. Substituting, we get so when you substitute now, we are told coefficient of friction is 0.15. This one, that's the coefficient of friction, 0.15. The mass of the box is 20 kgs. Then acceleration due to gravity is 9.8. So we just substitute those. (0.15). Then the mass is 20 kgs. Then acceleration is 9.8. That. We get the friction force like this. So this gives us our friction force 20, 0.5, 20 times that. So we get our friction force to be how much? 0.5 times 20 times 9.8. 0.15 times 20 times 9.8. I have 29.4. What do you have? Okay. 29.4 mass Rm. Newtons. So what do we see here? We see that the box experiences two forces in the x direction. Okay? The first force is this one, the reaction force. The reaction force is to the is to the right. It has got a size of 40 newtons. The box also experiences a friction force of 29.4 newtons. It is to the left. However, as we can see, the reaction force is greater than the friction force. Okay? Is this clear of the way to see? That the friction force is less than the reaction force. Is this clear? Yes. Therefore, this is the reason why the box appears to move backwards because there is a net force to the right. Is that clear? That's why the box moves backwards. Is this clear?
Yes, sir.
Yes. So, in the horizontal direction, that is in the x direction, the box experiences a reaction force FR, which is equals to 40 newtons. 40 newtons for to the right, and a friction force FF of 29. To the left. Therefore, since these two forces are not equal in size, there is a net force on the box to the right. We get this net force as follows. So for us to get this net force, always Fx is going to be equals to FR plus before we do that, we choose the direction in which the box is moving as the positive x direction. So that's going to be that. Then we're going to have a minus FF, which is going to give us FR minus this. So this is what we're going to get as our net force. So if you get that, substituting some numbers, we get Fx so we get the force, reaction force is 40 newtons. 40 newtons minus the friction force is 29. How much does that give us? 40 minus 29.4. 10.6. So we get the net force as 10.6 newtons. Is this clear?
Yes, sir.
Okay. So now that we have got the net force, then we can apply Newton's second law of motion on the box. Okay. Now that we have the net force, net force on the box, in the x direction, we can apply Newton's second law of motion on the box. And how does that look like? Begin equation Fx is equals to ma. We can do this. Oh, sorry. There's a summation missing there. Sum. We can do this. This bit we already have. It's 10.6 newtons. The mass of the box is 20. So we can find the acceleration of the box. The acceleration of the box is not equal to the acceleration of the car, as we are about to find out. So substituting. So where m is the mass of the box, a is the acceleration of the box. Also some fx is the net force on the box. M is the mass of the box, and that is the acceleration of the box in the x direction. Okay, so every bit thing explained here. So substituting. We get, so when we substitute the pieces of information we have, this is a net force, 10.6. The mass is 20. Where is it? Just write it. 20 kgs. And that is acceleration. A is acceleration. That's what. Oh, mistake. This. So we have got the resultant force. We have got the mass of the box. We can find A. Making A the subject. Making A the subject. We get the acceleration. The box as so in A is equals to at this. So how much would be our acceleration of the box?
0.53.
0.53 meters. Okay, so most of our job has been done. So now we know the acceleration of the box. We know, once you know the acceleration of the box, then you can predict everything else. We know that the box starts off from rest, which means it has got an initial velocity of 0. Then it covers a distance of 4 meters with this acceleration. Okay? It starts off at rest. It covers a distance of 4 meters with this acceleration. Therefore, we can actually predict the velocity of the box at the end of this acceleration. Then once we find that velocity, we can actually use it to predict the time it takes for the box to move this 4 meters. Is that clear? Okay. So, the box starts off with an initial velocity u, which is equals to 0 meters per second. Math rm meters per second, and accelerates. The acceleration value is this one we have just found. A equals to this. That's while covering a distance of 4 meters. S is equals to 4 meters. While covering a distance of 4 meters. Therefore, we can calculate the final velocity of the box at the end of the 4 meters. 4 meters using the formula Is this argument clear? The box starts off with initial velocity 0 meters per second, then it accelerates with this rate, and it covers a distance of 4 meters, then it falls off. By the time it covers a distance of 4 meters, this box has got a certain final velocity. Is that clear?
Yes.
Yeah, it has got a certain final velocity. So we can find that. So we can say begin v squared is equals to u squared plus 2as. We can use this. Once you know the acceleration, Newton's second law of motion is there to help you find the acceleration. Once you know the acceleration, you go back to these formulas for straight line motion. These. Okay? So, substituting, we get thing we got, that is the acceleration is what bit, and of course the distance is 4 meters. So when you substitute this, what you get that. Dropping off units, we get a more compact form of this. That's 3. So how much we get? How much is this? 0 squared plus 2 times 0.5 times 4. 0 squared plus 2 times 0.53 times 4. How much is that?
4.24.
Yeah. You got 4.24. That. Then take the square root of that. Then taking the square root, you get final velocity of box as it falls off as so that this gives us how much? The square root of 4.24.
0.06.
Huh?
2.06.
Oh. .06. So we have that. So that will be the final velocity of the box as it falls off. So with this information, the initial velocity is 0 here. Initial velocity is 0. We know the distance. We know the acceleration. We know the final velocity of the box as it falls off, 2.06 meters. We can find the time it takes the box to cover the distance, 4 meters. Okay. Next, we try to find the time it takes the box to fall off. Using the formula, A is equals to V minus U divided by T. So we use this formula here. A, the acceleration, is equals to final velocity minus the initial velocity divided by t. We know the acceleration. We now know the final velocity. We know the initial velocity. The only thing we do not know is the time. Is that clear?
Yes, sir.
Yeah, so we make the time the subject of the formula. So making time t the subject the formula we get t is equals to that divided by a. Get this. T is equal to final velocity when initial velocity divided by a. Then we substitute the values, substituting the known values of v, u, and a. We get the time t as follows. So final velocity is that. Initial velocity is 0. The acceleration of the box is that. So this is what you have. Looks messy a bit. So again, say dropping off units, we get  get this, which is also equals to that, which is equals to how much? How much is this? How much time do you have? Do you get?
3.89.
Yeah. 3.89 seconds. Mm. 3.89. So it takes the box 3.89 seconds to fall off. That's what you found out. So it takes the box 3.89 seconds to fall off from the back of the truck. That's what you found out. Is this clear?
Yes, sir.
Okay, but this 3.89 seconds, in this 3.89 seconds, the question is asking us how much distance, find the distance the truck travels when the box will fall off from the rear. So they are asking us how much distance has the truck covered in this 3.89 seconds. Is that clear?
Yes.
Yes. So if we know the time, we also know the acceleration of the truck. This is the acceleration of the truck. So the time it's going to take, the time the truck will have to travel is 3.89 seconds. And we also know the acceleration of the truck. We can predict, and we know the initial velocity of the truck, because we are told the truck starts from rest. Okay? So the initial velocity of the truck is known. The initial velocity of anything starting from rest is 0 meters per second. Then the truck undergoes an acceleration of 2 meters per second for a time period of 3.89 seconds. That allows us to find out how far the truck has moved. Is this clear?
Yes, sir.
Yes. So, since the truck starts off from rest, the initial velocity of the truck is u is equals to 0 meters per second. The truck undergoes an acceleration of a equals to 2 meters per second squared for a period of time it takes the box to fall off the back of the truck. Therefore, the truck moves for time t is equals to 8.39 rem second. We can, with this information, we can find out the distance covered by the truck using the formula begin equation. S is equals to ut plus 1/2 at squared. We can use this. U is the initial velocity of the truck, which is 0 meters per second squared. T is the time you have found, 8.39 plus half. The acceleration of the truck is 2 meters per second. Then the T is 3.89 meters per second squared. Is that clear? Yes. So substituting, we get But looks very messy. So as usual, dropping off units, we get that. There is 0 times that, so that becomes this bit disappears. This. There is half times 2, then that. So clearly that bit also kind of becomes very simple. That becomes just, the whole thing just becomes this. That. Right?
Yes, sir.
And how much is that now? Just a minute. How much does this become?
15.1. 15.1.
Yeah. So 15.1 meters. There. So the truck travels a distance of 15.1 meters before the box falls off from the back of the truck. There. Are we clear?
Yes, sir.
Okay. Any questions? About what we have done?
No question.
Okay. If there are no questions, so here this is where we started. We started with the fact that if a truck accelerates forward, everything in the truck is going to experience an acceleration backwards. That is a reaction force, and that is how we work out the reaction. The reaction force is equal to the mass of the thing in the truck times the same acceleration as with which the truck moves forward. In this case, since the truck is moving forward, the reaction force is backwards. And we found out the reaction force is 40 newtons. Because this reaction force is making the box move backwards, the box experiences a friction force, which is opposite the direction in which the box is moving. Since it's opposite, the friction force is in the same direction as the truck. Okay. Then we also are aware that the box just slides. It doesn't fly off. Therefore, in that case, so we know that the friction force FF is equal to the coefficient of friction times the normal force, but because the box doesn't fly off, we conclude that the normal force is equal to the weight of the box. Therefore, we work out our friction force to be this times that, and we found our friction force to be 29.4. We compared the 29.4 friction force and the reaction force 20 newtons. So we saw that the reaction force is greater than the friction force. So since these two forces are not equal but they're opposite in direction, there has to be a net force, and in the x direction, and this is what we found out. The friction force, and we chose the direction in which the box was moving to be positive, hence the reaction force being positive and the friction force being negative, and we found a net force of 10.6 newtons acting on the box. From this net force acting on the box, we applied Newton's second law of motion. We found here the net force is 10.6, the mass of the box times acceleration. We found an acceleration of 0.53 meters per second. With this acceleration 0.53 meters per second, and since the box was starting from rest, 0 meters per second squared, and underwent this acceleration and covered a distance of 4 meters, we used this information to predict what the velocity of the box is going to be as it falls off. And that's how we ended up with a velocity of 2.06 meters per second. Now that we knew the final velocity, we knew the initial velocity, we knew the distance covered, we were able to work out how much time it would take the box to fall off. And that's how we ended up with this time of 3.89 seconds. In this 3.89 seconds, the track covered some distance. The track underwent an acceleration of 0.2 meters per second squared. It was starting from rest, therefore its initial velocity was 0 meters per second squared, and it took 3.89 seconds. Therefore, we use this information in combination with this formula to predict how much distance the track is going to cover. So basically the track is going to cover a distance of 15.1, or roughly around 15. Are we clear?
Yes, it's clear.
Okay, so we're going to stop here. The PDF is going to be uploaded to Moodle this very moment, and I will try to upload the video recording to YouTube and later on to Moodle so that your friends who could not access it can actually access it. All right, and we can only solve one question since we're doing 1 hour. So see you tomorrow, same time. In the meantime, also, since you're back, I encourage all of you to continue attending the normal tutorials. Is that clear?
Yes.
Yes. All right, so you have come to the end. So I'll stop sharing. Yeah.